So today we're going to be looking at zero and negative exponents. Now most of you are probably very familiar when your exponents are all positive. So 3 to the first, 3 squared, 3 to the third, and 3 to the fourth. So let's fill in the ones that we're comfortable with and that we're familiar with. So 3 to the first is 3. 3 squared is 9. Be careful, if you wrote down 6, make sure you erase it or cross it off. This is not 3 times 2, it's 3 times 3, which is 9. 3 to the third is really 3 times 3 times 3, so this is 27. And 3 to the fourth is 81. Now, you can also use a calculator for that. 3 to the first we know is just 3. Now, we do have the exponent button here for squared to the second power. So if you want to do any number that's not squared, you have to use this little, I kind of call it the triangle button. That's the raising it to a power. So 3 to the first, that's how we would type that, is 3. You can just use the squared button for 3 squared, so we know that's 9. 3 raised to the third power, that's how we would type that one in, and then 3 to the fourth, and so on. So I just wanted to make sure you know how to do that on your calculator as well. Now, we do need to try to figure out what 0 and then the negative numbers are. So I drew a line with my blue highlighter showing everything above the blue lines. These are ones that we're very familiar with because they are all positive. It's the part underneath this first blue line and then even down into the negatives that gets a little tricky. Now before I just kind of give you the answer, I want to try to help you figure out the pattern why this is working. So I'm going to show you another example with the 2's. So again, we know all of the positive exponents, so we could go higher, 2 to the 6th, 2 to the 7th, and so on. The problem that we're running into is we don't know what to do with the things that come before what we know. Now, same thing with 4's. So I already wrote those down. We can start with 4 to the first and work our way up, or 2 to the first and work our way up. But then we kind of get stuck in math and we don't know how to work our way backward. So let me give you a quick overview of how this is going to work out. So if I do 2 to the first is 2, 2 to the second is 4. What I'm really doing is just multiplying the previous number by 4. Or excuse me, not 4, 2. That's not what I meant. I was looking at the 4 when I wrote that down, so I apologize. So we're going to do 2 to the first power is 2, and then we just take that number, if we want to raise it to the next exponent, multiply it by 2, which is 4, multiply this by 2, which is 8, multiply this by 2, which is 16, and multiply this by 2, which is 32, and we continue that pattern. So we know the pattern as it's going up. So in math, if we're trying to figure out something previous to that pattern, we want to work backwards. We want to go in reverse or do the inverse of the operation we were doing. So let's start up here. So we know 2 to the 5th is 32. Well, if I work my way backwards, instead of multiplying by 2, we want to divide by 2. So if I do 32 divided by 2, I get 16. If I work backwards, 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And then I continue that pattern, because in math, whatever you do, you just keep repeating that. So I'm just going to keep dividing by 2. So here, when I get to 2 to the first is 2, if I divide 2 divided by 2, that's 1. 1 divided by 2 is 1 over 2. Now I know some of you might want to put 0.5. Let's stay away from decimals right now. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. 1/8 divided by 2 is 1/16. And if we do that divided by 2, we get 1 over 32. So some of you may start to notice a pattern. Oh, look at that. 2 to the 5th was 32, and 2 to the negative 5th was 1 over 32. 2 to the 4th was 16. 2 to the negative 4th, it's not negative 16, it's 1 over 16. Same thing happens here. 2 to the third is 8. 2 to the negative third is 1/8. 2 to the second is 4. 2 to the negative 2 is 1/4. So notice how that pattern continues. So the negative exponent is just the reciprocal of the positive exponent. So you'll notice that pattern here. Same thing would happen with the 4s. So if I wanted to, if I do 4 times 4 is 16 times 4 times 4, that is going to continue all my positive answers. But if we want to try to figure out something that happened before that, we're going to do the inverse operation. So 256 divided by 4 is 64. 64 divided by 4 is 16. 16 divided by 4 is 4. 4 divided by 4 is 1. 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. You're going to notice a pattern. 4 to the negative third is 1/64. And then 4 to the negative fourth is 1 over 256. So hopefully you're starting to experience and understand the pattern that we're seeing. Again, a negative exponent did not make a negative answer. It is the reciprocal of its positive exponent. Okay, so now let's go back to our notes. And you're welcome to write any of those examples down that I showed you, but let's go ahead and fill this out now. So we know 3 times 3 is 9, times 3 is 27, times 3 is 81. So now we need to do the opposite. 81 divided by 3 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1. Now, you might want to make a little reference to yourself. How did we get 1? Because you might forget. So we're doing the reverse operation. When we went this way, we did times 3. Now you don't have to write this down every time, but because this is in your notes, it might be helpful so that you remember, oh, when I went this way, when I went up, I would multiply times 3 times 3 times 3 times 3, but to reverse the pattern, to figure out the prior answers, I need to divide. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. And notice 3 to the negative 2 is the reciprocal of 3 to the positive 2. So just keep that in mind. And we're going to talk about what negative exponents means in just a moment. But a kind of a good little hint is negative exponents are the reciprocal of its positive value. So tens, let's go ahead and fill this out real quick. We know 10 to the first is 10. 10 squared is 100. 10 to the third is 1,000 because we just do 10 times 10 times 10 times 10. But to reverse the pattern, to get down here, divide by 10, divide by 10, divide by 10, and 10 divided by 10 is 1. Hopefully you're starting to notice a pattern of what all of these zeros are. So look what 2 to the 0 was. Look what 4 to the 0 was. So any number to the 0 power is not 0, it's 1. 10 to the negative first, it's the reciprocal of 10 to the positive first, so 1/10. 10 to the negative 2 is the reciprocal of 10 to the second power, so 1 over 100. Now, real quick, before we go on to the examples, let's finish off this video. I know it's getting a little long. We're almost done. Let's put for every non-zero number a, so 0 can't be the base. So we're talking about all numbers where the base is not 0. A to the 0 power is 1. So again, the base can't be 0. The negative exponents for every non-zero number a to the negative n is just 1 over a to the positive n. So what we did was we just took the reciprocal, and it's the same value as the positive exponent. So right here, again, 10 to the second is the same as 10 to the negative 2, it's just the reciprocal. 3 squared is 9, 3 to the negative is 1/9, so it's the reciprocal. So negative exponents are the reciprocal of its positive value. Now what some students will do is they'll just say, oh, if it's negative, you just flip it down. And or you move it down to the bottom. So that's just what the reciprocal is. The fancy way is to say reciprocal, but some students say flip it, move it, and so on. So anything that helps you remember that would be a great tool to use.